Hello students, I hope you all are doing good and preparing well for your KCET exam. Okay, so today I have got this chapter, three-dimensional geometry. Okay, uh, so from this chapter you can expect around 3 to 4 marks in your KCET exam. Okay, and I have divided today's video into two parts. So in the first part, I want to revise the basic concepts, some important concepts that are useful, and in the second part we will be solving previous year questions. So I have I'll be discussing some techniques through which you will be able to solve the questions in a faster way. Okay. Okay, so let's start today's session. So first, what we have got is the concept revision. So what are the important concepts that we have? Say, okay, let's start. What is a position vector? Say we have got a point here. Say this point is minus 5 comma 4 comma 3. Okay, so let me call this point O, D. Okay, so when I join O with D, what I get is a position vector. OD is called position vector of point D. And how do I write this? It is minus 5 I cap plus 4 j cap plus 3 k cap. This is my position vector. This is called position vector. Next, coming to the concept of free vectors. What are free vectors? Free vectors are, say I have got this OD vector, right? Now I, keeping its magnitude and direction same, I can move this OD vector anywhere. I can give it parallel displacement. I can keep it here, I can keep it here. Okay, this is my OD vector, right? I can keep it here. My magnitude should be same, right? Okay, this is just approximate thing. I can keep it anywhere I want. So I can move those vectors. That is called free vector. So this idea is very important. The entire chapter is based on this idea of free vectors. Any vector can be moved along the parallel lines, along any of the parallel lines, keeping its direction and magnitude as same. Direction and magnitude. Okay, done. Next, moving on, the third concept that I want to recollect is finding the vector given its endpoints. Say we have got these endpoints A and B. Okay, so there is a vector AB. Okay, if this is a vector AB, so direction ratios of vector AB, how can we find? So see, 3 minus 1, that is 2, 4 minus 2, that is 2, and 5 minus 3 is 2. So corresponding components we will subtract. Okay, so this will give us direction ratios of vector AB. So this technique we will be using frequently. Given any 2 points, we will be finding the direction ratios of that vector. Okay, AB. Similarly, and these two conditions you need to know. Suppose we are given two vectors and say they are parallel. So these are the direction ratios of those vectors. Suppose, okay, a1 comma b1 comma c1, a2 comma p2 comma c2. These are two vectors, and if I want to check that these two vectors are parallel, how do I check? I just have to take the ratio of their corresponding components. A1 by A2 equal to B1 by B2, C1 by C2. So corresponding components. So if they are in proportion, I can conclude that these two vectors are parallel. Okay. So how do I check whether they are perpendicular? For perpendicular, the condition is that dot product should be equal to 0. A dot B, suppose whatever the two vectors are, say the two vectors are v1 and v2, then their dot product will be 0, right? So that is what I have done. This is the dot product. So each of the component I have multiplied, it should be 0. So this is how we can check whether two vectors are parallel or perpendicular. Okay, very important. Okay, so now we will go to the interesting part, the KCET PYQ questions. Okay, let's start. So what have we got here? So let vector A I cap plus 2 j cap plus k cap, vector B equal to I cap minus j cap plus k cap, and vector C I cap plus j cap minus k cap. A vector in the plane of A and B whose projection on C is 1 by root 3. Okay, so there is a faster way to solve this. Okay, so first we need to know the formula for finding projection of vectors. So let's recollect that. So projection of vector V on U is given by this formula. you know, right? It is given by this formula. V vector dot product of V bar V and U, and divided with the magnitude of the vector along which we want. So along U bar we want, so it is divided along U vector U, magnitude of U. Similarly, so what I'll be doing here is I'll be doing the substitution method. I'll pick the options and check which of these satisfies. I'm not taking into consideration what is A and B. Okay, A and B ko I'm ignoring. This is not required. Okay, I'll just check. So if we pick option A, okay, and our vector C is this one. So what we are trying using a substitution method, what we are doing is projection of this vector, option A on C. We are trying to find that out. So our option A, we have got this vector, projection of this vector on C. So we'll be using this formula. So dot product divided by magnitude of vector C bar. Here we have already found out the magnitude of vector C. So substituting, we get 9 by root 3. Okay, so 9 by root 3 is not equal to 1 by root 3. 1 by root 3 they have already given. So moving to the second option, we have got 4I minus j plus 4k cap. So again, dot product of this vector with the C vector. Okay, and divided by magnitude of vector C. So this is the magnitude, right? This is the magnitude of vector C. So on substituting, I'll get 1 by root 3. So see, this second option satisfies, right? Second option is satisfying. So the correct answer is option B. So here, as you can see, I have not used vector A and B. So the question said, which of the vector has the projection of C bar as 1 by root 3. So I just took the options and substituted and I checked. So option B is working. So my correct answer is option B. Okay, this is a faster way in which you can solve. Moving to our next question. It is an interesting question. Okay, again, what have we got? Okay, so equation of the line passing through the point. Okay, they have given the point and parallel to the line of intersection of the planes. Okay, intersection of these two planes. So we need to find the equation of line that passes through the point 2 comma 3 comma 1 and is parallel to the line of intersection of these two planes. Okay, so we already have the point. So we need a vector which is parallel to the intersection of these two planes. Intersection of plane can be found out by cross product of the normal vectors of the planes. Okay, so normal vectors. So from these two equations, so we have got, let me call this plane 1 and plane 2. From plane 1, I have to extract what is my normal vector. Normal vector is nothing but coefficients of x, y and z. So I cap minus 2j cap minus k cap. Similarly, normal vector of my second plane, I'll call it n2, and it is I cap the coefficients of x, y and z. As you can see, it is 1, 1 and 3. So I cap plus j cap plus 3k cap. So the cross product of these, the normal vectors is nothing but a vector which is parallel to the intersection of these two planes. Okay, that is very important. Intersection of plane is the cross product of normal vectors of the plane. So this is important. This information we'll be using. And here what I have done is, let us call the vector u as our vector u as our the intersection of the plane. So the cross product, I have the normal procedure for cross product I have done, and I have got this vector. So this vector is parallel to the intersection of these two planes. So the point they have given in our question, and we have found out the parallel vector. So using this, I can write my equation. So x minus 2 divided by minus 5 equal to y minus 3 divided by minus 4 equal to z minus 1 by 3. We know, right, uh, if a line is passing through x1 comma y1 comma z1 and is parallel to this vector, say uh, a I cap plus b j cap plus k c k cap, then the equation of line, let me call this vector d. Okay, so let it be. So I have a line, equation of line which passes through this point and is parallel to this vector. How is it given? X minus x1 by a, y minus y1 by b, and z minus z1 by c. That is what I have done here. So what is our correct option? Correct answer is option a, right? X minus 2, yes. Option A is fitting. So this can be easily solved in a minute. You need to know that intersection of two planes can be found out by cross product of their normal vectors. Okay, important. Moving to the next question. So here they are asking us foot of the perpendicular drawn from the origin to the plane. Say this is our origin. So this is our plane. Say, so from origin if I draw, so this is 90 degrees, this is in 3D. So coordinates of this point they are asking us. Okay, we can find that out. So we know what is the standard equation of a plane? R bar R dot n cap equal to D. Okay, so they have given us the Cartesian form 2x minus 3y plus 4z equal to 29. Again I have written it in vector form. So in vector form, as you can see, here it is normal vector is n, but we need to have a unit vector, unit normal vector. So I want n cap. Here it is vector n. I want a unit vector. So my normal vector is 2i minus 3j plus 4k cap. The magnitude of my normal vector is root 29. So now if I divide this equation by root 29 on both the sides. Okay, now the form of the I have transformed this into this form, r vector dot n cap equal to d. So uh, this is my standard equation of plane. Now to find the foot of perpendicular on plane, that can be found out using d into n cap. Okay, so we have already found out the distance. Okay, this is the distance. This is nothing but 1 by root 29. No? Sorry, root 29. Our d is root 29. So we have using this comparing with the standard equation, we have found out what is our d. D is root 29. So we need to find out the foot of that perpendicular from origin to the plane. We have to find out coordinates of this point. Let me call this A. So coordinates of A, we already know what is d. Okay, and the direction also we know. So to find coordinates of A, OA is nothing but d n cap, right? Everyone agrees? Okay, we have found out what is d. We already know O. Then OA is nothing but d and n cap, because n cap, this the direction is n, the normal vector. So if I put my values in this formula, I get this vector 2i cap minus 3j plus 4k cap. So this is a position vector. From that, what is the position? I can extract the position, right? 2 comma minus 3 comma minus 4. So this is my position vector. So this is my foot. These are the coordinates of foot of the perpendicular. So the correct answer is 2 minus 3 comma 4. So correct answer is option A. Moving on. What have we got? So this is a slightly easier question. The vector equation of the plane, which is at a distance of 3 by root 14 from the origin, and normal from the origin is this thing. So what is the information they have given? Let's write that down. So the distance they have given us. Okay, distance of the plane from the origin is 3 by root 14, and normal vector they have given us. So normal vector of the plane is given. From that I am finding out the unit normal vector. So n cap is nothing but vector n divided by magnitude of n. So this is our unit vector, unit normal vector. So the standard equation of plane, what do we know? R dot n cap equal to d. D is, what is d here? The perpendicular distance from the origin to the plane. That is already given, 3 by root 14. So all I have to do is substitute in this formula. So what do I get? On simplifying, I get this, right? So my correct answer is option A. Yeah, option A is fitting, right? So my correct answer is option A. So this can be easily solved in a minute. Let's move on to our next question. So it is also slightly easy question. So what have we got? Find the coordinates of the foot of the perpendicular drawn from the origin to the plane. Okay, so to understand this visually, I have tried to plot this plane on the xy planes, on in the 3D. See, this is our 3D plane, x, y, and z. So our plane, if I simplify this equation, 5y plus 8 equal to 0, what do I get? Y equal to minus 8 by 5. So this is actually equation of plane. So my x and y coordinate can be anything, but my y coordinate should be 8 by minus 8 by 5 only. So if I plot this plane, it will be something like this. So all the points lying on this plane have their y coordinate as minus 8 by 5. Okay. So they are asking us what is the perpendicular drawn from the origin to the plane. So this is our perpendicular, right? This will be our perpendicular. So what are the coordinates of this point? What will be the coordinates of that point? Because it is lying on y-axis, okay, and it is lying on our x plane. Sorry, as you can see, the x and z coordinates will be 0, right? Because uh, because y, okay, y is 0 comma minus 8 by 5 comma 0, okay. So it is 0. Why it is 0? Because we are on the y-axis. On y-axis, coordinate of x coordinate will be 0, and our z coordinate also will be 0, okay. That is why the coordinates of the foot of the perpendicular drawn from the origin is 0 comma minus 8 by 5 comma 0, okay. Since the point is lying on the y-axis, its x and z coordinate will be 0. So what is my correct answer? Correct answer is option D. So this is an easy question, a very easy question. You need to visualize the plane on the plane in the 3D. If you can do that, this can be easily solved under a minute. Coming to the next question. So here I have tried to solve this in a faster way. Actually, I have written down each of the steps. So this question might look lengthy, but this can be solved maybe in 1 minute 20 seconds or 1 minute 30 seconds. Okay, easy. Okay, so what they are asking us, the distance of the point minus 2 comma 4 comma minus 5 from the line. So this thing. So from the given data, let's extract whatever things we have got. Okay, we have got this point. Let me write that down. Minus 2 comma 4 comma minus 5 and the equation of the line they have given. From the equation of the line, I can extract what things I can extract. So from this, I can extract the point from which the line passes. Those coordinates are nothing but this, no? Minus 3 comma 4 comma minus 8, and the parallel vector is nothing but the denominator, 3, 5 and 6. So these things are found out. Okay, so let me just put them here. So let me call this point, this is our line, okay, this is our line, this is our parallel vector, this is the point through which the line passes, okay. And this, let us call this as point B, minus 2 comma 4 comma 5 minus 5, and let D be the distance, okay. So we need to find this distance T, okay, and we have got this AB, AC. So everyone is clear till here, right? B is already given, and we have found out the coordinates of A, and this is our parallel vector B, okay. So what is AB? I have found out what is AB. You can find out, given the coordinates of the endpoints, the vector can be found out. All we have to do is the corresponding components we have to subtract. So I have got what is vector AB, okay. So I have got AB. So my D, we need to find out here D. If you observe here, what is my D? D is nothing but AB sine theta. Everyone agrees? It is the vertical component. It is the vertical component. If you do simple trigonometry, you will get D equal to AB sine theta. So AB sine theta, I can write it as AB cross product of AB and B divided by magnitude of B. If I simplify this, I'll get again AB sine theta, right? So for this, I need to find out what is the cross product. So the cross product I have found out between vector AB and vector B. So this is the cross product. So this is our vector, the cross product, and this is the magnitude. And this is the parallel vector, and this is the magnitude of parallel vector. I have substituted all the values here in this equation. So I get so and so. On simplification, we get minus root 37 by 10. Okay, under root. So the correct answer is option C. Let me summarize again. So from this equation, we found out the point through which this line passes and the parallel vector. So that is minus 3 comma 4 comma minus 8, and the parallel vector is 3i plus 5j plus 6k cap, right? Okay. Next, what we did was we found out the vector AB. So point B is nothing but, I have chosen this as my point B. Okay, so AB, and my this distance is nothing but AB sine theta. Okay, AB sine theta, and to find AB sine theta, I have used the cross product and I have found out. So this is a very important question. Okay, very important question. So he has asked repeatedly, So you can go through this solution once again and practice this. You can expect a question similar to this, because every year he has asked a similar question. So this is a very important question. So uh, practice this type of question. Coming to our next question, what have we got? The perpendicular distance of the point P from xy plane. Okay, very easy question. So let this be our point. Let me call this point 6 comma 7 comma 8. So it is given already. Okay, so so they are asking us the perpendicular distance from the xy plane. So this is my xy plane. Everyone agrees? This is my xy plane. So they are asking us this distance. What is this distance? Simple, right? The coordinate, the z coordinate, whatever is the z coordinate of this point, that will be my uh, d distance. Okay, this is my xy plane. So what is my d? D is nothing but the z coordinate of this thing. Z coordinate is 8. So correct answer is option 8. So this question can be solved in 10 seconds. Okay. See, if you read the question, so you get 50 seconds extra. You can utilize those 50 seconds somewhere else. Okay. So this was a very easy question. Moving to our next question, what we have got, the plane. The plane 2x minus 3y plus 6z minus 11 equal to 0 makes an angle sine inverse alpha with x-axis. The value of alpha is equal to. Okay. So we have learned this, right? They are asking us, so alpha, so let me just write step by step. So the equation of plane they have given us. Through the equation of plane, I have written down the normal vector. So they are nothing but the coefficient of x, y and z. 2 I cap minus 3 j cap plus 6 k cap. So this is my normal vector. So x axis, I can represent x axis using I cap. Everyone agrees there? So that is the trick here. Okay, we know the angle between a vector and a line, angle between a plane and a line is given using this. Here, n is the normal vector of the plane and b is the parallel vector of the line. Parallel vector that is parallel to the line. So using this is the standard formula that we know. Acute angle alpha between a plane and a line is given by this, right? Sine inverse alpha equal to n dot b divided by magnitude of n and b, multiplication product of n and b. So all we have to do is substitute in this formula. We have got our vector n and our vector b, that is I cap. So here this is my vector n and my I cap is nothing but my b bar. If I substitute all the values here, I get my sine inverse alpha. Okay. So sine inverse alpha is 2 by 7. So this is a very easy question. So all we have to know here is the acute angle between a plane and a line is given by this formula, right? Sine inverse alpha. Alpha is the acute angle, n dot b. Okay. The angle alpha is the angle between the plane and the line. Plane and line. Here our line is nothing but x-axis. So a vector which is parallel to x-axis, I am taking b bar as I cap. That is the trick here I have done. This is the trick that you need to apply. So I cap is a vector that is parallel to x-axis. Everyone agrees? So that is how we can solve this question using this equation. You need to know this formula, right? This is the standard formula that you get in your NCERT textbook. Okay, moving to the next question. Again, this is an easy question. The reflection of the point alpha comma beta comma gamma in xy plane is, okay. So let me draw the 3D surface. So say this is our xy plane. So this is my xy plane. Okay. And let us take this point alpha comma beta comma gamma here. So the reflection of point uh, about xy plane. Okay. So if I take the reflection about xy plane, so see, on xy plane the z coordinate is 0. Everyone agrees? On my xy plane the z coordinate is 0. So what will be coordinates of this point? Alpha comma beta comma 0, right? My xy coordinate will be same. Again in the same direction I am going downwards. So my alpha comma beta will be same, but my z coordinate will change, right? It will become minus gamma. Okay, right? Everyone agrees? Alpha comma beta comma minus gamma. So this is the correct option. So the correct answer is option B, alpha comma beta comma minus gamma. So along the xy plane they are asking us to find the reflection. So your xy coordinates remain same, the z coordinate sign changes. Okay. Coming to the next question, what have we got? The image. So this is also a very interesting question, and you can expect this question. This question is important. Let me just, same question you can expect. Okay. The image of the point 1 comma 6 comma 3 in the line, this line, this is the equation of the line. So we have to find, so let me extract the all the data we have got. So from this equation, x1 equal to y minus 1 by 2, z minus 2 by 3. I can extract the point that is 0, 0, comma 1, comma 2, and the parallel vector b bar is 1, 1 I cap plus 2 j cap plus 3 k cap. That is what I have written here. This is our point and this is the parallel vector, right? Everyone agrees here? Okay. So let my point be 1 comma 6 comma 3. Let me call this p. This they have given. They have only given us, right? So the technique that I'll be applying is, say, I'll be using the substitution method here. Okay, option substitution. Say I is the image of the point P. So if I is the image, everyone agrees here. See what will happen to my AP. AP and AI. AP and AI are equal, right? You will study this in physics, right? These two, this can be proved using a congruency rule. Simple thing. AP is equal to AI. Everyone agrees here. AP is equal to AI. So this information, this is a very crucial information that we'll be using to solve. So what is my AP? AP is, see this AP, we have got 2 points. I have to just subtract the corresponding components. So I have got OP and OA, 1 comma 6 comma 3, 0 comma 1 comma 2. So I get 1 comma 5 comma 1. So I get I cap plus 5j cap plus k cap. So this is my AP. This is my AP. So what is the magnitude of vector AP? It is root 27. So I want a point I such that magnitude of AI is equal to root 27, right? So I'll use the substitution method. So let me take option A. Let us take the image of the point as 1 comma 0 comma 7. What do I get? I get uh, here I need to find out this vector, right? AI. So what is my AI? So I have to subtract their direction ratios, corresponding direction ratios. I get root 27. So see, this thing agrees. So this is working. So my AI is equal to AD. I have found a point using substitution method that this point satisfies. But one more condition I have to check. There are many points. There are many points. See, there are 100 millions of points, infinite points, such that magnitude of AI is equal to magnitude of AP. But one more condition we have to check here. Key before applying the shortcut. Key this line, say PI. Let me call this line as PI. My PI will be perpendicular to my parallel vector. Everyone agrees? Will be parallel to my parallel vector because that is the image of the point. So the dot product will be 0. I have to check this condition first before I can confirm that this is my image. So what is my PI? PI can be found out. And what is my vector B? Vector B is already given. So we have found that out. So the dot product is 0. So this is a check that we have to do. Okay. So the dot product is 0. That means my this point 1 comma 0 comma 7 is the image of the point. Image of the point. So this is a very important question. You can expect a similar question in your exam. Similar question. Okay. So go through this question once again. If you have not understood, you can ask me in comments. I'll try to explain it again. Okay. Coming to our next question. Yeah, this is a very easy question. So they have given us the equation of the lines and they are asking us what is the angle between those lines. So these equations we have to transform them into standard form. So here x 2x I have written x divided by 1 by 2 equal to y divided by 1 by 3, z divided by minus 1. Similarly here I have taken x divided by 1 by 6, y by minus 1, 3 z by minus 1 by 4. So these are the parallel vectors of the line. From the denominators I can extract the parallel vectors, right? So these are my parallel vectors. So if we know the parallel vectors, the formula is cos theta b1 dot b2 divided by their magnitudes, product of their magnitudes. So In numerator only I am getting 0. If I evaluate the numerator, I am getting 0. That means cos theta is equal to 0. What does that mean? My theta is equal to 90 degrees. Everyone agrees, right? Okay. So this was an easy peasy question. Moving to our next question, what have we got? So this is a very easy, very good question again. The value of k such that the line x minus, so this they have given the parametric form of the line, lies on the plane. Okay. So they have given us the equation of the line. From the equation of the line, what all things we can extract? The point that the line passes through. So here it is 4, comma 2, comma k, right? It passes through this point and it is parallel to this vector 1 1 2 I cap j cap 2 2 k cap. From the uh, equation of the line, I have found out these two data points. So we have got this, they are telling us the line lies on the plane. That means this point also lies on the plane. This point should satisfy equation of plane. Everyone agrees? Okay. So I'll just substitute the coordinates of this point on my equation of plane. So if I substitute, I'll get the value of k. So this is a trick question. It can be solved in a minute easily. So the correct answer is option D. Okay. We have found out that point and we are substituting the coordinates in the equation of the plane. Equation of plane is already given to us. In that we are substituting and finding out our value of k. Moving on. Okay. The locus represented by this equation. Okay. So this equation, if I simplify, I'll get something like this. Right. If I take y common, y times of x plus z. So here from this I can write y equal to 0, x plus z equal to 0. These are nothing but equation of planes, right? So this, if this is my equation of plane, what is the normal vector that I have? I only have j, okay, j cap. So for this plane, my normal vector is I, coefficients of x and z, I cap plus k cap, right? So I have got the normal vectors of these two planes. If I take the dot product of these two vectors, I'll get 0. What does that mean? That means these two planes are perpendicular because their dot product is 0, right? So the locus represented by this equation is nothing but a pair of perpendicular planes. Okay, pair of perpendicular planes. Okay, moving on. Okay, so this is a good question. Foot of the perpendicular drawn from the point 1 comma 3 comma 4 to the plane 2x minus y plus z plus 3 equal to 0. So they are asking, so let's visualize the things. So we have given this point 1 comma 3 comma 4. So they are asking, say this is our plane. So foot of the perpendicular. So we need to find out the coordinates of point F. Okay. So from the equation of plane 2x minus y plus z plus 3 equal to 0, we can find out the normal vector. They are nothing but the coefficients of x, y and z. 2 I cap minus j cap plus k cap. Okay, their direction ratios are nothing but again the coefficients. I have written the direction ratios 2 comma minus 1 comma 1. So this is my vector that is normal to the plane. So here the technique that I will be using is substitution method. Okay, say option A. Okay, say our option A is F, point F. So see here, if correct answer is option A, let me call that as point F. My normal vector and these two vectors PF. Okay, these two vectors are parallel, right? These two vectors are parallel. This information we'll be using to solve. So my FP is parallel to my normal vector, right? So here, what is my point P? It is 1 comma 3 comma 4. So taking option A, that is minus 1 comma 4 comma 3, what is my FP? I need to subtract the corresponding components. I'll get the direction ratios of vector FP. Okay. Similarly for option C, option D, and option C and D, option B, C and D. I have to see whether this vector PF is parallel to my normal vector. If it is parallel, then I can confirm that my vector F, then my point F, uh, I need to just find out whether they are parallel. How do you check that the two vectors are parallel? Their corresponding component should be in ratio, right? We discussed initially. A1 by A2 equal to B1 by B2 equal to C1 by C2. Everyone agrees, right? So I have found out the PF, vector PF for each of the options. So see in which of the case uh, it the components are in proportion with our normal vector. So as you can see, option A and option D both satisfy. Option D also you can see the components are in proportion with the components of vector n, right? Okay. So see here 2 points are satisfying this condition. So how do we eliminate now? One more condition is okay. So 2 points are satisfying. I need to check whether this point lies on my plane or not. Whether, so we have got 2 points A and D which satisfy our conditions. It should satisfy one more condition. These 2 points must lie on the plane. If they lie on the plane, they should satisfy this equation. Everyone agrees? So let me put these values in the equation of plane. So what do I get on substituting minus 1 comma 4 comma 3? Yes, option A satisfies. Let me check for option D, minus 3 comma 5 comma 2. Sorry, minus 3 comma 4 minus 3 comma 5 comma 2. Let me check that. We have got 2x minus 5 plus z plus 3 equal to 0. Let me substitute 2 comma minus 3 plus, sorry, minus 5, no, plus 5 plus 3 equal to 0. 2 3s are minus 6 plus 5, sorry, here you get plus 2, no, plus 2 plus 3. So this is not equal to 0, right? So option D does not lie on the plane. That means my correct answer is option A. Option A is the correct answer. So using substitution method we have done. Okay, so this is also a very important question. You can expect a similar question in your KCET. This is an important question. Similar question you can expect. Moving on to our next question. So this is a slightly easier question that we have got. The acute angle between the line and the plane is directly. They have given us the equation of the line and the equation of the plane. From the equation of line, we can find out the point that it is passing through and the uh, parallel vector. From the plane, we can find out the normal vector. So the direct formula that we have is sine theta n dot b divided by product of their magnitudes. So we'll be directly substituting in that and we'll get sine theta. Okay, sine theta we have got 9 by 2 root 39. But there is no option that matches this. Okay, there is no option. So I'm going to my cos theta. Cos square theta is 1 minus sine square theta. So this is my cos square theta. So my cos theta comes out to be this thing. So my theta is equal to cos inverse of 5 by 2 root 13. So that is how you can find this out. This question can take slightly more time, maybe 1 minute 20 seconds to solve, not more than that. But if you know what to do, you will be able to solve it much faster. If you no need to think, okay, so this is the given thing, I know the direct formula, I can substitute and find out. Okay, moving on. So this is an interesting question. XY plane divides the line joining the points A, B in the ratio. They are asking us to find out the ratio. Tell me how on XY plane, the what kind of points do I have? I have points whose z coordinate is 0. Everyone agrees on xy plane the coordinate z coordinate will be 0. So this data I'll be using. Say let point O divide the xy divide points A and B. Let these be let these are my AB and O divides. O is the point that divides. So the coordinates of O will be x1 comma y1 comma 0 because my z coordinate is 0. Let us take the ratio as k is to 1. Okay, k is to 1 to simplify for simplification of things. I have the direct formula k z2 plus z1 divided by k plus 1. I have to just substitute here. I know what is z2, what is z2. Z2 is minus 3 and z1 is minus 5. If I substitute here, I get, and if I simplify, I'll get the value of k. So you need to know two things here. The coordinates of z on xy plane is 0 and the section formula you need to know and apply. K z2 plus z1 by k plus 1. Okay, these two things you need to know. So the correct answer is, because this is minus negative, this is externally, not internally. Okay, D, option D is my correct answer. Okay, so again this one is an interesting question. They have given us if the vectors 2 I cap minus 3 j cap plus 4 k cap, 2 I cap plus j cap minus k cap, and lambda I cap minus j cap plus 2 k cap are coplanar, then the value of lambda is okay. So all these three vectors lie on the plane. All these three vectors are lying on my plane. Let me call them A, B, and C. A, B, and C. Let me call this C. Let me call this B. If I take the cross product of AB, so that vector will be perpendicular to this plane. Everyone agrees? A cross B. So I have found out the A cross B vector. Let us call the first vector as A, the second vector as B, the third vector as C. The cross product of vector, if we find that out, we'll get this thing. Okay. Minus I cap plus 10 j cap plus 8 k cap. Now, this vector is perpendicular to the plane and our vector C lies on the plane. So what happens to the dot product? So A cross B dot C, because they are perpendicular, the dot product will be 0. If I use this information and find the dot product, I'll get the value of lambda. Okay, that is how you can find this out. So the value is 6. So this is a good question. You can expect a similar question maybe. Coming to the next question. So this is an easy question. If a line makes an angle pi by 3 with each of x and y axis, then the acute angle made by z axis is, okay. So with x and y axis, it makes pi by 3. Pi by 3 is nothing but 60 degrees, right? Everyone agrees? And with z axis, they are asking us what is the angle. Let me call that gamma. So we know this standard equation, right? Cos square alpha plus cos square beta plus cos square gamma equal to 0. I have to equal to 1. Okay, this is the standard formula that you need to know. You should know. Okay, I'll just substitute here. What do I get? Cos square alpha is nothing but cos square 60 plus cos square 60 and cos square gamma equal to 1. So cos 60 is 1 by 2, 1 by 2 whole square is 1 by 4, 1 by 4 it is 1 by 2, 1 minus 1 by 2 is 1 by 2. So cos alpha is 1 by root 2. So it is 45 degrees, right? My gamma is 45. 45 is pi by 4. The correct answer is option A. So I think that is all I have got for today's session. No, one more question I have, sorry. So this is a standard direct formula substitution. The distance of the point with position vector from the plane. They have given us a point, the position vector of the point and the equation of the plane. They are asking us to find out the distance. So we know this standard formula, right? So say vector n is the normal vector, okay, and d is 4 here from the equation. We know the standard formula that you read in your textbook, in your book. A dot n cap minus d divided by magnitude of n. So direct substituting the values in the formula, you can find that out. Okay, this is an easy question. You can expect a similar question, maybe similar. Okay, this is also an important question. Okay, that is all I have got. I have tried to solve the question in faster methods, faster way, so that you can save your time. I hope this session was helpful to you, and I would suggest you to practice problems from exemplar book and miscellaneous questions from your NCERT textbook. Okay, so that would be helpful, and along with that, solve previous year questions. So that way you can score easily the 3 to 4 marks that will be appearing from this chapter. Okay. So thank you, students. You can one more thing, you can join my Telegram group, so that you will get the latest updates. Okay. So please like and comment whatever, if this how you felt this video. Tell me in the comments. Okay. If there are anything is required, we'll implement that in the next video. Okay. Thank you.